In this short Grasshopper tutorial, I want to show you how you can make an algorithm by defining a series of obstacles here and also a path. So this is like a polyline and it has a different height in different locations. And I'm going to move that person around this. So here you can see if it intersects. The minimize goal, which we're going to use the Galapagos plugin, is going to go to the roof, which is really a high number, and it's going to fail. So if I move this around, you can see that when it doesn't intersect, we have a smaller number. But the goal is to make this number as small as possible. So for example, here you can see that we even can reach like 13. And what we're going to do is define a goal as a surface. And assume that this is the goal. We are looking at this and we want to maximize the view. So what we are going to do here is going to compare a series of vectors. One vector is going to be, assume that we have the centroid of the goal and the person here, and make a vector towards that person. Okay, so this is going to be one of the vectors, I guess. This is the vector. Okay, so this is the vector we are looking at, the base goal or the base surface. We also have a normal vector for this surface, which is this one. Okay, so what we are going to do is to make two planes. One is the normal direction is one of the vectors, and also assume that we have this x direction on the surface. So it's going to make a plane like this. Okay, and we're going to project this view on that plane. So this is one of the vectors of the projection of the view, and it will have a degree with the normal of the surface. Okay, we have to make this as small as possible. So if this is 0, it's actually exactly in the normal direction. Another plane we're going to make is this plane. As you can see here, it's going to be again in this direction and the normal view, and this is going to be a plane. Again, we're going to project the view we have onto this plane, which is going to make this vector here. And we're going to compare also this degree. So we have two degrees here. One is A and B. And if we add these together, we want to make this as small as possible. So at the end, we're going to add those two vectors together and make this as small as possible. We will also test if it has intersection or not. So this is going to give us an output, and we will multiply that with the added angles. And this is what we want to make the smallest. So if I just double click the Galapagos and say I want to minimize it and give it an initial boost, so it's going to produce 500 different solutions, I can go to the solver, see the display and start it. And it's going to try to put the person all around the path and take a look at this goal. And then it's going to sort it from smallest to biggest. As you can see here, this is the goal and we are trying to minimize this one. So it's going to run it. And if I just hit stop, it's going to stop. But anyway, it's going to optimize till we have the smallest number possible. Anyway, I'm going to stop this. And if I go for the first simulation, you can see that we have 500 different solutions. Obviously, these big numbers are those which are really, really big because they have intersected the obstacles. So this number is really big, but if we just scroll and find a small number in the list, for example, starting with 178, it doesn't intersect, but it has a really bad view. As you can see here, this is how we are looking at this surface. The angles are really high, especially in this plane. It's like when we projected in this plane, we have a 90 degrees difference, which is going to add up. And for the first simulation, we have this optimized view, which is near the normal direction of the surface or the goal surface. So 6.2, it's going to optimize that to 6.1. It's just going to move it slightly the path. If it's really complicated, it's going to try to optimize it. So I just wanted to show you how you can make the logic in Grasshopper. So we're going to talk about this algorithm and see how it works. Okay, let's take a look at the algorithm. I'm going to turn off everything and explain the inputs.